Hello friends, today we will discuss about this problem, and this problem is based on Kcl voltage law and Kcl current law. Here you see this is the circuit element, this is the resistance, these are two voltage source and one current source. You have to calculate the current through the resistance R2, that means 5 kilo ohm, and the current through R3, that means 6 kilo ohm I3. Okay, so in this circuit you have to calculate these two parameters I2 and I3. So now I will calculate these two values with help of Kcl voltage law and Kcl current law. First of all, you should know that if I able to calculate the node voltage of this circuit, then it will be very easy to calculate the current at any branch. Okay, so first of all we should identify what is the node. Here you see that this is a one node, so you can call it A, and this is another node, this you can call it B, and this is another node, you can call it C. Okay, so every node have a node voltage. So if I take VA as a node voltage of node A and VB is the node voltage of node B and VC is the node voltage of node C. Now this node C is grounded, that's why this is the value of VC will be 0. So the node voltage of node C must be 0. Now we will apply the KCL at every node. So step number 1. Step number 1, applying KCL at node A. Here this is a node A. We do not know the direction of current of this node. That's why we assume that all our current are leaving from this node. All our current are leaving from the node. So we assume that all current from this node are leaving from this node. After calculation, I will take the value of different current, branch current I1, I2, I3. Okay. So if I take it positive, then the direction will be same. But if I get negative value, the direction will be reversed. So first of all, I assume that all the current from this node are leaving. Okay, so how to write this KCL? You should notice number 1, this is there will be a current in this direction, there will be a current in this direction, there will be current in this direction. So current in this direction will be voltage of A minus voltage of B divided by 10 kilo ohm. This is the one current through this. So VA minus VB divided by 10 kilo ohm. If I take this, then the current will be in milliampere. Okay, plus this is the another branch, this is V A minus this voltage is 0, so VA minus 0 divided by 6 kilo ohm plus this current 2 ampere. So this is the one KCL equation of node A. So if I take this is, it will be 30. So 3 VA minus 3 VB plus 5 VA plus 60 equals to 0, or it will be 5 at 8 VA minus 3 VB equals to minus 60. So this is the equation number 1. Okay, the equation KCL equation of node A. Now steps to applying KCL at node B. So this is a branch, this is a branch, this is a branch. So current will flow in this direction, in this direction, in this direction. Okay, so using this no current along this direction will be VB minus, this is 10. So VB minus 10 divided by 5 plus current through this branch will be VB minus VA divided by 10. Okay, so current through this branch, it will be plus VB, this is a minus, okay, this is plus, this is minus, this is minus, this is plus, so it will be VB minus of minus 8, so it will be plus 8 divided by 2 resistors are connected in series, so it will be 12 plus 4 must be equals to 0. So here it will be VB minus 10 divided by 5 plus VB minus VA divided by 10, and it will be VB plus 8 divided by 16 equals to 0. This is the another equation. Now if I want to simplify this equation, so it will be 80, so or it will be 80. So here 16 VB minus 160 plus 8 VB minus 8 VA plus 5 VB plus 40 equals to 0. So or VA is 8 VA, so minus 8 VA. VB is 16, 8 and 5, so it will be 29 VB. Okay, and this one minus 160 and this is plus 40, so it will be minus 120. If I take this into this side, so it will be 120. So this is the equation number 2, KCL equation number 2. So if I solve these two equations, we will get voltage, node voltage VA and node voltage VB. So by solving, so if I add this two equation if I add, so adding equation 1 and 2, so this and this will be cancel out, and here will be 29 VB minus 3VB equals to 120 minus 60. So it will be 26 VB equals to 60. So VB equals to 60 divided by 26. 60 divided by 26. So it will be 2.308 volt. So VB will be 2.308 volt. Now if you put this value at any of these two equation, you can calculate the VA from, if I put this value of equation number 1, so what will be the value? It will be 8 VA minus 3 multiplied by 2.308 equals to minus 60. Okay, minus 60. So 8 VA equals to minus 60 plus, if I multiply this two value, 3 multiplied by 2.308, it will be 6.924. So VA will be minus 53.076 divided by 8. So it will be minus 6.635. Okay, so VA is this. So I get the two node voltage VA equals to minus 6.635 and here is VB equal to 2.308. Now you have to calculate I2. What is the I2? I2 is VB minus 10 divided by 5. So VB, I have already calculated the value of VB. VB is 2.308 minus 10 by 5. So if you calculate this value, then it will be minus 1.538. It must be milliampere. Okay, it must be milliampere because this is in volt and this is in kilo ohm. That's why it is milliampere. So minus 1.538 milliampere. Now if you want to calculate I3, so I3 is node voltage VA minus 0, this is node voltage 0 divided by 6. So here is the node voltage of VA is given by this, so minus 6.635 divided by 6, so it will be minus 1.10 approximately 6. Okay, it will be milliampere. It will be milliampere. So both these current are negative. So direction of the current will must be in this direction. Okay, in this direction. So using the sign convention, we can say that the direction of current I3 will be along this direction and direction of I2 will be along this direction. Okay, so this is the problem. Here you should apply this technique to solve a. Here you see this another two problems. Okay, this problem you have to calculate the current through 80 ohm resistance. 80 ohm resistance. So all this problem I will try to solve using Kcl voltage law and Kcl current law. Okay, so here number 1. So here you see this is a node. Suppose this is a node A. So this node voltage suppose VA. So if I want to calculate this current through this resistance 80 ohm, we have to calculate the node voltage at node A. So first of all, we should calculate the value of node voltage VA, okay, at node A. So applying KCL at node A. What will be the equation? KCL equation. Current through this junction. Current through this junction is VA minus 50 divided by 4, and current through this junction, current through this junction 20 ohm, it will be plus VA divided by 20 and VA divided by 80 equals to 0. This is the KCL equation at node A. How to calculate? This current VA minus 50 divided by 4. This current is VA minus 0 divided by 80. This current is VA divided by 0 divided by 20. Okay, this is the KCL equation. Now if I simplify this equation, then it will be 80. Okay, so 20 VA minus 1000 plus 4 VA, it will be VA equals to 0. So it will be 5 and 20. That means 25 VA minus 1000 equals to 0. So VA equals to 1000 divided by 25. So it will be 40 volt. Okay, so node voltage is 40 volt at node A. Now if I want to calculate the current through this resistance 8 ohm, so this current will be current through 80 ohm resistance. So I at 80 equals to VA divided by 80. So it will be VA is 40, this is 80, all are ohm and volt, so it will be ampere. So half equals to 0.5 ampere. So current through this resistance 80 ohm is 0.5 ampere. Now this problem, what is this problem? Problem number 2. Here this is a circuit, this is a resistance R. This problem given that V1, this node voltage is 40 when the value of R is 10 ohm. So when calculate the value of V2 when r equals to 0, r equals to 0. If you carefully notice this circuit, that a V1 node voltage, V1 node voltage, V1 node voltage does not depend on R, value of R, because the current through this junction in this way, so the node voltage V1 does not depend upon this value of R. So whatever the value of R, the node voltage V1 will remain same. So when R equals to 0, then these two nodes are same. Two nodes are same. When R equals to 0, then two nodes are same. Two nodes same means V2 must be equals to V1. So value of V1 is 40, so it will be 40 volt. Okay, this is a simple strict question. Okay, so this is the question related to Kirchhoff voltage law and Kirchhoff